Have you ever stopped to think about the invisible world around us? It's filled with signals and messages. These carriers are responsible for connecting us in ways that would have seemed impossible just a century ago. This hidden network is like a giant silent orchestra playing with signals called waves. They carry our voices, songs, and movies. They are the backbone of our modern connected society. Understanding this invisible orchestra is key to understanding how our technology works, like Wi-Fi and GPS. Today, we will explore radio waves and sound waves. They might seem similar, but their differences are what make our modern world possible. By the end of our journey, you will see how these two different kinds of waves work together to connect us all. Let's start with a whisper. Whispering creates sound waves, vibrations traveling through the air. For longer distances, technology converts your voice into electromagnetic waves, like radio waves. Think of your home Wi-Fi. Your router encodes data onto radio waves which travel through walls to your devices. From whispers to Wi-Fi, we constantly interact with sound and radio waves. Radio waves are long-distance champions, carrying information across vast distances. Understanding this difference helps us appreciate the technology that powers our communication. To truly grasp the difference between radio waves and sound waves, we first need to understand what a wave is. At its core, a wave is simply a way of transferring energy from one place to another. Imagine you are at the edge of a calm pond. If you toss a small stone into the water, you will see ripples spread out from where the stone landed. Those ripples are waves. The water itself isn't actually traveling across the pond. Each water molecule is mostly just moving up and down. What is traveling is the energy you gave the water when you threw the stone. This is a great analogy for how many waves work. Now let's apply this idea to sound. A sound wave is very much like the ripple in the pond, but instead of water, it travels through other materials which we call a medium. When a drummer hits a cymbal, the metal vibrates rapidly. This vibration pushes on the surrounding air molecules, creating areas where the air is compressed, and areas where it is spread out. This pattern of compressions travels outward as a sound wave. It needs the air molecules to carry the energy. Without a medium, like air, water, or a solid object, there is nothing to vibrate, and therefore, no sound can travel. This is a crucial point to remember about sound waves. Radio waves, on the other hand, are a completely different kind of beast. They don't need a medium to travel. They are a form of light, part of what scientists call the electromagnetic spectrum. This spectrum includes everything from the radio waves to the microwaves to the visible light, and even X-rays. These waves are created by moving electric charges, and they are self-propagating ripples in electric and magnetic fields. They can travel through the total emptiness of space just as easily as they can travel through the air in your room. This is the most fundamental difference between the two. Sound waves are mechanical waves. They are the mechanical vibration of matter. Radio waves are electromagnetic waves. They are fluctuations of pure energy that require no matter to exist. This is why we can receive signals from satellites and distant space probes. Those signals are radio waves, traveling through the vacuum of space where sound could never exist. An explosion in space might look spectacular in a movie, but in reality it would be completely silent because there is no air to carry the sound wave. To understand sound and radio, let's define what a wave is. A wave transfers energy from one place to another. Imagine a pebble dropped into a pond. Ripples or waves spread out, carrying the pebble's energy. A leaf on the surface bobs up and down as the wave passes but doesn't move across the pond. The water molecules stay in place, passing energy to their neighbors. Like a stadium wave, energy moves, but the medium, water or people, stays put. This principle applies to sound waves and more. The need for a medium separates sound and radio waves, defining their unique properties. Let's zoom in on sound waves, a type of mechanical wave. These waves need a physical medium to travel through. They can't exist in a vacuum. Sound is essentially a vibration passed through a substance. Imagine a cymbal vibrating, pushing air particles together, compression, and then leaving space, rarefaction. This chain of vibrations travels outward, and we perceive it as sound. Sound travels faster through solids than air because particles are more tightly packed. In space, there's no medium, so there's no sound. No stuff, no sound. Radio waves belong to the electromagnetic family. Unlike mechanical waves, they don't need air or water to travel. They are pure energy, traveling through the vacuum of space. Radio waves are a form of light, part of the electromagnetic spectrum. This includes microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Radio waves are generated by moving electric charges. Accelerating electrons create ripples in electric and magnetic fields. This is how radio waves spread out in all directions. Their ability to travel through a vacuum makes them essential for long-distance communication with satellites. They connect our planet and carry our curiosity into the cosmos. The fundamental difference between radio and sound waves: do they need stuff to travel through? Sound waves need a medium, like air or water, because they are vibrations of matter. Without particles, sound cannot exist, leading to silence in space. Radio waves, however, are electromagnetic and need no medium. They are self-propagating energy ripples. This allows global and interplanetary communication. Radio waves effortlessly cross the vacuum of space. Sound is tied to matter. Radio waves are free, carrying messages to the stars.
Let's go. I wake up to a little bit of drool on my pillow, feel like it's gonna be a bad day. Yeah, I'm tired of shit, and the coffee ain't hit yet, damn, ain't that great. I don't wanna go to work, cause my boss is a jerk, and I'm not even that paid. I need a change in my life, cause I don't feel alive, and there's nothing that makes me happy. Hold my beer for a minute, I'm about to quit my job, cash in for a ticket. I'm going on a trip, and I don't plan to visit. I'm gonna stay there till I feel like I'm winning,
Ultimate speed limit. The way sound and radio waves propagate reveals their distinct characters. Sound, a mechanical wave, travels outwards in a spherical pattern, like ripples in a pond but in 3 dimensions. As the sound expands, its energy spreads, which is why it gets quieter with distance. Sound interacts with its environment, being absorbed and reflected by objects. Curtains absorb sound while walls reflect it, creating echoes. Radio waves, however, have a less interactive journey, especially in space. They also propagate outward, but because they don't interact with a medium, their path is cleaner. In space, a radio wave travels in a straight line unless bent by gravity. The signal weakens as its energy spreads over a larger area. Communicating across vast distances is challenging because the signal becomes incredibly faint. Powerful radio telescopes are needed to pick up these faint whispers from deep space. Let's discuss our own bodies. Every day, we are surrounded by sound waves that shape our world. We interact with our environment through hearing, dependent on the physical nature of sound. When your friend laughs, their vocal cords create sound waves that travel to your ear. These waves cause your eardrum to vibrate, converting it into electrical signals. Your brain interprets this as laughter. Our ability to speak creates sound waves to communicate. Our lungs push air past our vocal cords, creating vibrations. Our mouth shapes these sounds into words. Speaking is the art of sculpting air, carrying our thoughts to others. Sound waves deliver experiences to your brain. Without sound waves, our world would be silent. For communication that needs to cross distances, we need to employ radio waves. Our world is powered by gadgets that use radio waves to connect us. Your smartphone, laptop, and car keys all communicate wirelessly thanks to electromagnetic waves. The Wi-Fi router in your home broadcasts data as radio waves, letting your devices connect without wires. Listening to the radio in your car? That's a radio wave carrying music from a distant station, decoded by your car's receiver and turned into sound. Bluetooth headphones, TV remotes, and GPS all rely on different parts of the electromagnetic spectrum. GPS, for example, uses radio signals from satellites to pinpoint your location anywhere on Earth. These gadgets translate invisible radio energy into the sounds and images we understand. We live in a constant hum of wireless communication, a silent, high-speed network all around us. This network is the backbone of our modern society, connecting us and powering our daily lives. All of this is possible because we've learned to harness the power of waves that travel at light speed. Nature mastered wave communication long before we did. Whales and dolphins use sound waves to talk across oceans, while bats navigate with echolocation, bouncing sound off objects to see in the dark. Lions roar to warn rivals, birds sing to attract mates. Sound is their tool for survival. Animals exploit the physical properties of sound for communication and navigation. Meanwhile, the universe is filled with natural radio waves from stars, galaxies, and pulsars. For centuries, we only saw the cosmos in visible light, but radio telescopes let us hear the universe. We now detect signals from the Big Bang, map hydrogen in our galaxy, and listen to spinning neutron stars. These cosmic radio waves travel millions of years to reach us, telling stories of the universe's birth and structure. Just as animals use sound to map their world, we use radio waves to map the cosmos. Nature and technology both rely on waves to connect, explore, and understand. The language of waves is universal, spanning from animal calls to cosmic signals. Let's follow a phone call to see how sound and radio waves work together. You say hello. Your vocal cords create a sound wave that travels to your phone's microphone. The microphone's diaphragm vibrates, mirroring your voice's pattern. This vibration is a mechanical process, capturing the unique shape of your sound. But sound waves can't travel far, they fade quickly in air. The phone must convert this local vibration into a signal that can travel the world. It transforms your voice's physical energy into an electrical signal. This is the first step in turning a local whisper into a global message. The journey from your vocal cords to your phone is short, but the real magic is about to begin. Next, your voice will become a wave of pure energy, ready to travel at light speed. Now comes the highway of radio frequencies carries your message onward.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it.
World. We've explored the worlds of sound and radio waves, two very different messengers. Sound waves are mechanical, needing air, water, or solids to travel. They're tangible, local, and limited by their medium. Radio waves are electromagnetic, pure energy that travels through empty space. This makes them perfect for long-distance communication and cosmic exploration. Sound is slow and local radio is fast and global. Our ears are tuned for sound, but we need technology to hear radio waves. Gadgets like phones and radios translate radio energy into sounds and images we understand. Sound is native to our biology. Radio is a language we learn through science. Together, they connect us locally and globally. The story of waves is the story of connection from a whisper to the stars. In the end, perhaps the best way to think about the relationship between sound waves and radio waves is to use a final, simple analogy: the message and the messenger. The sound wave is the message itself. It is the rich, detailed, and meaningful content. Think of the unique tone of a loved one's voice, the complex harmony of an orchestra, or the specific information in a spoken warning. This is the original content, the thing we actually want to perceive. But this message on its own can't travel very far. It's like a beautiful letter written on delicate paper, too fragile to make a long journey by itself. The radio wave, then, is the high-speed, long-distance messenger. It is the sturdy envelope and the global postal service all in one. The radio wave itself doesn't contain the inherent meaning. Its job is to carry the message. Our technology cleverly places the sound wave's pattern, the message, onto the radio wave. The radio wave then acts as the tireless courier, carrying this information at the speed of light across cities, oceans, or even the solar system. It is the vehicle, not the passenger. Its nature allows it to overcome the distance that the original message never could. When the messenger arrives at its destination, its job is done. Your friend's phone receives the radio wave, opens the envelope, and extracts the original message. It then carefully reconstructs that message, turning the electrical pattern back into a physical sound wave. What you hear is not the radio wave. You hear a recreation of the original sound, the original message, faithfully delivered by its invisible, high-speed courier. This partnership is what makes our connected world possible. We use the best qualities of both waves, playing to their strengths. So, from the ripples in a pond to the signals from distant stars, the universe is alive with waves. We've seen that sound waves are the physical, mechanical vibrations that paint our immediate world with rich detail, and radio waves are the electromagnetic messengers that collapse distance and time, connecting us all. The next time you pick up your phone, listen to the radio, or connect to Wi-Fi, take a moment to appreciate this incredible dance. It is the beautiful, silent partnership between the message and the messenger, a scientific symphony that plays out around us every single second.